Now I'm going to do an example of graphing a rational function. So here's our example of a rational function, x squared minus 4 divided by x squared plus 2x plus 1. So before we start graphing it, we want to get all the necessary information, which means we need the x-intercepts, the y-intercept, the vertical asymptotes, and the horizontal asymptotes. Okay, so to find the x-intercepts, we want to set p of x equal to 0, but actually because it's a fraction like this, we only really need to set the top to 0 and solve that equation. So we have x squared minus 4 equals 0, so x is equal to plus or minus 2. Now to find the y-intercept, just like with every other function, we plug in 0 to p. When we plug in 0, we get negative 4 on the top and 1 on the bottom, so our y-intercept is at negative 4. Now to find the vertical asymptotes, we set the bottom of our rational function equal to 0 to see where we would be dividing by 0. And so when we do that, we can factor this as x plus 1 squared equals 0, so x equals minus 1. And that's our vertical asymptote. We can draw it right here. And to find the horizontal asymptote, remember we compare the highest powers of x that appear on the top and the bottom. And so in this case we have an x squared on the top and an x squared on the bottom. So we have a horizontal asymptote at the ratio of their coefficients. They each have coefficient 1. So we have a horizontal asymptote at y equals 1 over 1 equals 1. So here's our horizontal asymptote at y equals 1. And I've graphed the x-intercepts here and the y-intercept here. Okay, so now we want to go ahead and start graphing our function. We know that as the graph moves to the right, we're going to end up following this asymptote. And as the graph gets close to minus 1, we're going to end up following this asymptote. And we can see that it's going down here because it's below this horizontal asymptote, and because we plotted this extra point, which tells us that we can see the function is going down here. If you weren't sure whether a function should go up or down near the asymptote, just plot a couple of points near there to see what's happening. And actually we'll do that on this side. So now on this side, we can see that as we go towards the as we go towards the vertical asymptote, we must go down because we're below this horizontal asymptote, and because we can see that we have 2 points going down here. And I plotted this extra point so that we could see that. So if we didn't have this extra point here, we might not know that the graph goes down in this direction. In other words, that it's decreasing as you go this way, as you go towards the vertical asymptote. So what you do is you plot an extra point to get a sense of what's happening. So the point that I plotted was negative 3, 5/4. If you plug in negative 3 to this function, what you get is 5/4, and that point is about here. And now from these 2 points together, we can see that the function is decreasing as we go towards the vertical asymptote, so it's going downwards. Now what about towards the horizontal asymptote? Well, we see that the graph crosses the horizontal asymptote, but we know that in the end, as we go towards the left, it eventually has to follow it. So our graph looks something like that. The graph comes up, it passes through the horizontal asymptote, because we can see this point is above it, but then it must come back down and eventually follow that horizontal asymptote. And the reason it does that is, well, because that's exactly what a horizontal asymptote means. As the function goes very far to the left or very far to the right, it eventually follows the horizontal asymptote.